All right, let's talk about the internet. Not the websites you see, but the invisible rules running underneath everything. We're going to dive into the protocols that decide how your emails, your downloads, and even your video games get from point A to point B. You ever stop and think about this? How is it that when you're playing an online game, a little bit of lag is annoying but kind of expected, yet when you download a big file, it's perfect, every single time? The answer to that question comes down to a choice the internet has to make for every single thing you do: speed or reliability. And to really get that choice, we've got to go back to the beginning. We need to start with the OG protocol of the internet, TCP. Its whole reason for being can be summed up in one word: reliability. So TCP stands for Transmission Control Protocol, and you can just think of it as the internet's super trustworthy delivery service. Anytime you're doing something where losing even a single piece of data would be a disaster, like logging into your bank or sending a critical email, you can bet TCP is working behind the scenes. So how does it guarantee nothing gets lost? Well, let's use an analogy. Imagine you're mailing 10 books to a friend. Instead of putting them in one giant box, TCP breaks them up into smaller numbered packages. It sends them all out, and your friend on the other end starts receiving them. They might check and say, "Hey, I got packages 1, 2, and 4, but I never got number 3. TCP doesn't freak out. It just calmly resends that one missing package. The job isn't done until every single package is accounted for and put back in the right order. So with TCP, you get these rock-solid promises. All your data will show up, it'll be in the right sequence, and if anything goes missing along the way, it'll get sent again. It's safe, it's methodical, but as we're about to see, all that safety comes at a cost. You see, for the early internet, which was pretty simple, TCP was perfect. But as the web grew up and got way more complex, this super reliable protocol started creating a massive hidden traffic jam. I mean, just think about a modern web page, right? It's not just a single document anymore. It's this complicated mess of text, style sheets, code, a dozen images, maybe video, all trying to load at the exact same time. And this put a huge strain on good old TCP. So the first big attempt to fix this was a new web standard called HTTP/2. And its big idea was something called multiplexing. Basically, instead of opening up tons of separate, slow connections for every little file, it bundled everything into one single, efficient superhighway. And honestly, it was a massive improvement. But here's the mystery. If HTTP/2 was so much better, why have we all still had that frustrating experience where a web page just hangs? You're just sitting there watching that little loading spinner go round and round. If the problem was fixed, what was going on? And this is the wild part. The problem wasn't the new standard. The engineers had built a much faster car, but that car was still stuck in traffic. The real problem was the road it was driving on. It was still TCP. This gets us to the absolute core of the issue, a problem called head-of-line blocking. Because TCP has that super strict rule that everything must arrive in order, if one tiny packet for an image gets lost in transit, everything behind it, even completely unrelated stuff like the text for the page, has to stop dead in its tracks and wait. One lost packet can literally freeze the entire connection. So this freezing problem made it painfully obvious that TCP, as great as it was, wasn't the right tool for every single job. For some things, you need instant feedback more than you need perfect accuracy. You need speed. And that, my friends, is where UDP comes in. UDP, or User Datagram Protocol, is the total opposite of TCP. If TCP is our reliable book delivery service, UDP is like quickly scribbling a message on a postcard and dropping it in the mail. It's incredibly fast, but there's no guarantee it'll get there. No confirmation, no nothing. It's basically a fire and forget system. Now, you might be thinking, why on earth would anyone use that? Well, because for things like a live video call or a fast-paced online game, speed is everything. Think about it. On a Zoom call, you'd much rather have the screen get a little pixelated for a second than have the whole call freeze for 3 seconds while it waits for a lost packet from the past. Getting the newest information right now is way more important than perfectly getting old information. Okay, so for years, we had these two options: TCP, the safe but sometimes slow one, and UDP, the fast but unreliable one. Those were the choices. But the modern internet was demanding something better. It needed the best of both worlds, and that's where QUIC enters the picture. QUIC's main idea is it's so brilliantly simple.
It says, okay, let's start with the raw speed of UDP as our foundation, and then let's build the smarts and reliability of TCP on top of it, but in a much smarter way.
So remember that massive traffic jam problem, head-of-line blocking? Well, this is how QUIC completely solves it. The old TCP way is like ordering a burger, a pizza, and a juice. If the burger gets delayed, the pizza and juice are just stuck waiting behind it. But with QUIC, it's like each item has its own delivery lane. So if the burger gets held up, no problem. The pizza and juice can just zoom on by and get delivered on time. And QUIC is just packed with these modern superpowers. You get reliable delivery, just like TCP, and it completely fixes that traffic jam problem. But it also has security built right in from the very start, which makes connections faster and safer. And here's the absolute killer feature for anyone on their phone. It lets your connection switch seamlessly from Wi-Fi to your mobile data without dropping. No more stuttering video the second you walk out your front door. Because of all these huge advantages, the entire next evolution of the web, HTTP/3, is built completely on top of QUIC. This isn't just some small upgrade, it's a fundamental change in how the internet pipes work. So, with these three powerful tools in the toolbox, TCP, UDP, and QUIC, how do developers actually decide which one to use for any given task? Let's break it down. This table pretty much says it all. If you're downloading a file, you need every single bit to be perfect, right? So you use TCP. If you're playing a competitive online game where every millisecond counts, you need the lowest lag possible, so that's UDP. But for a modern, complex website or pretty much any mobile app today, QUIC is the obvious winner. It gives you the speed, the reliability, and that awesome resilience to network changes. Look, if you only take one thing away from all this, let it be this super simple memory trick. If accuracy is more important than speed, you want TCP. If speed is more important than perfect accuracy, you want UDP. And if you need speed, accuracy, and all the bells and whistles for the modern internet, the answer is QUIC. You know, this whole story is just a really cool lesson in how technology actually progresses. TCP wasn't a mistake. It was the solid foundation everything was built on. We didn't tear it down and start over. We just recognized where its limits were and intelligently built and evolved around them. And that, of course, leaves us with one last fascinating question to think about. QUIC solved the big traffic jam of today, but as technology keeps getting faster and crazier, what's going to be the next hidden bottleneck that starts to slow us all down? And what brilliant new solution are we going to have to invent to get around it?